Hello, and welcome to 5 Minute Math. Today we are looking at the 8th grade concept of dilations. This is standard 8.3b in the great state of Texas, and we are using item number 13 of the 2025 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. All right, so we've got a triangle, PQR, dilated to form triangle P prime, Q prime, R prime. And look at the original PQR is this little guy right here. So this is definitely a scale up. So if we're thinking of scale factor, it's going to be a larger number because look how much larger the P prime, Q prime, R prime is. So we need to find a true statement. All right. So take a look at this. Triangle PQR was dilated by a scale factor of, see, it's not going to work. 1/3. Well, let's just take a look. Let's look at P. P is 1, 3. So if I were to use this right here, what I would get is you should think that then P prime would be that 1/3 times that 1, and then that 1/3 times that 3. And that would give you my new coordinates, which would make P prime 1/3, 1. That would be a much smaller. That's actually not how it works. So actually, we reversed it. If you go from P prime down to P, you scale it by 1/3. So P prime to P is 1/3 scale factor, but you never go from P prime down to P. You go from P up to P prime. So that's inverted. 1/3 is correct, but we need to take the reciprocal of that. Looks like we're going to go 3. Let's see, PR, so now we're just making a ratio here. So PR, I'll put that in blue. So PR is aligned with P prime R prime. Okay, so far so good. See how those two sides are aligned with each other. So now what I need on the other half is a small side with a large side. Let's put those in green. RQ, R prime, Q prime with RQ, but you notice that they're opposite, right? This was a the large triangle and this was the small triangle. And that's not going to work. If we were to flip these, we would have been good. We would have had the small to small and the large to large. So that's not going to work. All right, so P prime, Q prime, which is, let's just make it magenta here, is 3 of this. But we don't know what that length is because we'd have to use the Pythagorean theorem. But we do know that that scale factor does seem like it's 3, right? So R is 1, 1, and R prime is 3, 3. Look at this, Q is 4, 1, and the Q prime is 12, 3. You see how they both scale up by 3? So yeah, if you triple PQ, you are going to get P prime, Q prime. So this looks like it's good. Okay, and let's just double check D here. Triangle PQR is congruent. Now it comes down to a key word here. We cannot say they are congruent because congruent means same size, same shape. They are the same shape, it just got scaled up. They are no longer the same size. Instead, when you scale up with the dilation, they are similar. Now, if that were to say similar, then that would be the correct answer. Similar means same shape, but just proportional sizes. The angles stay the same. But it doesn't say similar, it says congruent, which they are not. They are not the same size. So D is incorrect, which means, yes, our answer is going to be C. If you triple PQ, you will get P prime, Q prime.